In this video, we will be learning how to find reactions at supports. If we are given this simply supported beam with a pin support and a roller support and a force acting on it, how do we find the reactions at the supports? So step number one is always to find the free body diagram. We will redraw it, and instead of the pin and roller supports, we will put forces. So at A, let's just assume that the force is going up. We have two forces, one in the Y direction and one in the X direction, because this is pin. So let's assume there are these directions. You could flip them, it doesn't matter, because we will find out at the end which direction is correct. So let's call this a Y because it is in the Y direction, and let's call this a X since it is in the X direction. So we also have this force right here given 400 newtons, and at point B we have a roller support. Now with the roller supports, they only have a force in one direction, and this will be in the Y direction. So let's also assume that it is upward. Now we have our free body diagram. The second step is using equilibrium equations, because we know that this simply supported beam is in equilibrium. So we have three equations for equilibrium that we could use. And the first one is the sum of the forces in the X direction is equal to 0. And we will take this direction of X to be positive. So let's see what forces we have in the X direction. It looks like we only have AX, which is in the positive direction. So since we have nothing else, we have to equate it to 0. So this is the first force that we found. The second equation of equilibrium is going to be in the Y direction. So sum of forces in the Y direction is equal to 0, and we will take the positive direction to be upward. The forces we have are AY in the positive direction minus 400, since it is in the negative direction, plus BY going in the positive direction equal to 0. So from here, we have two unknowns. That means we cannot find AY or BY simply from this equation. We need a third equation. And that will be the sum of moments. Sum of moments about a point, we can choose any point, is equal to 0. Now, a good way to choose the point you will be using is looking at which point has the most forces that we do not know. That is because at that point, those forces will not contribute to the moment, so they will just be equal to 0. As we can tell from this free body diagram, that is point A because we have AX and AY. We could easily choose B as well, but for this example, we will just choose A. So the sum of forces about A, and we will take the counterclockwise direction to be positive. Now, moment is equal to the force times the perpendicular distance between the points. So let's see for point BY. That is going to be BY, the force, times what is the distance between this force BY and point A? It is this whole distance, which is equal to 0.8 plus 0.2. That is equal to 1 meter. And now we have to find the sign. Is it going in the positive direction or the negative direction? So let's see. If we hold it right here, because this is where we are finding the moments about, hold this about point A, and let's imagine we have this force pushing up. If we are holding it right here, pushing up will make this whole beam go in this direction, right? So if it's going in this direction, that means it is counterclockwise, which means this is positive. Let's move on to the next force we have, 400 newtons. Let's start off, before putting the sign, by calculating the value. So it's 400 times the perpendicular distance between the force and our point. So again, this distance, how much is that? It is given to be 0.2 meters. So now we need to find if it is plus or minus. So again, let's imagine we're holding it right here at point A, and this force is pushing down on the beam. Clearly the beam is going to go in this direction. So if you complete the circle, keep going to figure it out, we notice that it is going in clockwise. Clockwise is negative, so we'll put negative sign right here. Now, AX and AY will not contribute to this moment equation. Why is that? Because it is true that we have forces. However, there's no distance between the force and the point. It's zero distance. So simply the moment is going to be zero, and we will not include them. If we go back to our equation here, we will just set this equal to 0. We only have one unknown, so we can easily find By. And if we calculate By, we will get it to be equal to 80 newtons. Now, we can use this value right here, plug it back into this equation to find AY, because we only have one unknown after that. So if we do that, AY is going to be equal to 400 minus By, which is 400 minus 80, and that is 320 newtons. So we have found all of our forces. If we had gotten this value to be negative, that means that our assumed direction was wrong and we should flip it. So let's say we got AY to be equal to minus 320. And I'm talking about a different example in case you encounter this later. So if it is minus 320, that means that our free body diagram, we assumed that AY is up. But since we got a negative value, we have to change it. And now we know that AY is actually going down. So that is the only thing I wanted to point out. But in our example, AY is positive, so our assumed direction was correct. BY was also positive, our assumed direction was correct. And AX, well, is 0, so it doesn't matter about the direction. And that is how we find the forces at the supports.